Hi, everybody. Today is maybe the day that you have been waiting for this entire unit. Today we're going to talk about the quadratic formula and how you use it and when to use it and how to make sure that your answers are right. So we are still in learning target 4B, and I know that this feels like we've been in this learning target a long time, but there really are just a lot of strategies that I'm expecting you to be able to use in this strategy. The one that we're going to focus on today is quadratic formula, but we are going to go through pretty much every other strategy on this slide because I want to make sure that you know how important it is to be flexible about using multiple strategies. Notice that these are the strategies that are on the list, and so if you're using a different strategy from these, I might know that you're using outside resources, and I'm not saying that that's necessarily a bad thing, but I do want to make sure that you have the ability to do this independently without using photomath. I'll just say it. I don't want you to use photomath on these problems, especially when you're taking an assessment. Okay, so we are focusing on the quadratic formula, and we'll go through it in a second. I'm not going to sing the song or anything, but you can sing it in your head. Reminder that there are 5 strategies to solve these equations. These are the strategies that I'm hoping you will use. Here we go. Okay, so we sort of simplify the quadratic formula down to just saying this, but it's really important that you have to know that you have to have an equation in standard form. You have to be in standard form for you to be able to use the quadratic formula. And so we will just kind of go through this one as an example for how you would use that. Notice that I am in standard form. And so that means that I'm good to go. The most important thing to check is to make sure that you have an equals 0 on one side. If it doesn't say equals 0, then that means that you have to do something to get it to that point. So maybe you have to add or subtract some things from one side or the other side to get all of the stuff over here and just have a 0 here. So let's see. What I'm going to start with is, and maybe this isn't going to help you very much, but I want to just be really clear. I want to start with what A is. A is 2. B is, on this problem, it's a -7. And then C is also negative. It's -17. Be careful about what's negative and what's positive. Remember that there is usually a plus and a plus here. But since this is a minus and this is a minus, you have to do something to deal with that information. So what I'm going to do is I'm just going to rewrite the entire quadratic formula, except instead of writing a B, the A, and the C, I'm going to write the numbers that I have. So here we go. X equals, it's really important that you say X equals because otherwise it's not a true statement. Negative, B was -7, so I'm going to write -7 like that. Plus or minus the square root of -7, -7 squared, minus 4 times A times C, all over 2A. Now this is a big, huge simplifying problem at this point, and I do want to go through this one really slowly this time, just because I want to make sure that we follow the order of operations correctly, and you come up with something that is complete and correct. So -7 is 7, +7, plus or minus the square root of, okay, -7 squared is +49. A lot of you are just going to type -7 squared in your calculator and you're going to get -49. But remember that we're also squaring the negative, and that we're squaring the negative because we're squaring the entire B term, and the entire B term is -7. It shows it right there. Okay, so 49 minus 4 times 2 times -17. So I'm just going to do that in my head. Well, actually, I'm going to use my calculator, but I'm going to think about what is 4 times 2 times -17. and I get negative 136. Okay, so then what I'm doing is I'm doing minus negative 136, all divided by 4. Okay, notice that this fraction bar goes all the way underneath the entire thing. If you don't do that, you're going to get a wrong answer. 49 minus 136 is 185. So I'm going to rewrite 7 plus or minus the square root of 185, all divided by 4. I should be writing x equals every time. Okay, now I'm not even going to simplify this anymore. I'm going to circle this answer right here because I'm happy with that. That is an exact answer, and I don't need to go further with this. You could put this in your calculator and get an answer like decimals. You could get a decimal answer, and that would be fine. You should have 2 of them. So you should have 2 decimal answers, one with a plus and one with a minus here. That is the quadratic formula. So I'm going to just kind of zoom out so that we can see the whole thing. There it is. Moving on. This is U. This is a problem that does not need the quadratic formula. So if you're using the big sword on the problem that doesn't need the quadratic formula, that indicates to me that you're not really understanding why you should use it versus why you should use other strategies. So I am really going to be looking for, when do you use the right strategies? Not that there has to be a right strategy, but there are better and worse strategies for one problem or another problem. So I might be asking you, why did you choose that method? Give me some evidence for what you see in the problem so that you know what strategy is best for this problem. By the way, for your reference, this problem is just x squared plus 2x equals 0. I noticed that there's a common x in both terms, so I could factor it out and rewrite on the inside x plus 2 equals 0, and then I could zero product property. So I could say x is 0 or x plus 2 is 0. And so I get x equals negative 2 on this one, and my other answer is x is 0. This is a way easier way to do this problem. It's faster, it's more efficient, it's kind of more mathematically sound than trying to use the quadratic formula. So don't be the person who uses the sword when you don't need to. Okay, so the big problem with all of this is figuring out how to pick a method. And so this is sort of a checklist that you should work from the top to the bottom on. And you should always start by thinking, can you just get x by itself? Can you? If not, then can you factor? If not, then can you complete the square? If not, then it's fine, use the quadratic formula. If the quadratic formula gives you some issues, then you should think about using your calculator to calculate where the graph crosses the x-axis. So I'm going to keep this list on every slide today, just so that you have that list, and we're going to refer to it every time. And I'm going to just do a bunch of sample problems. What I want you to do on these problems is I want you to pause the video right away. I'm going to give you a second. I want you to try the problem first, and then I'm going to go through what I would do for this problem. So here's your opportunity to try this problem right now. And here we go. Okay, so by the way, for your reference, you might see some different types of variables in the next couple of lessons. This one is the Greek letter gamma. We handwrite it like that. I know it doesn't really look like what this looks like, but that's just the fancy font that I use. This is the Greek letter gamma. Okay, so it doesn't do anything different from X. It's just that you might see different symbols, and I would just want you to be used to that. So let's look at this. Number one, can we just get the variable by itself? And this gives us a hint. Are we in vertex form? No, we're not. We're in standard form. And it says, are we in standard form with b equal to 0? And we can see that b is 5. So no, we can cross off strategy number 1. That's not going to work. Does it factor? Now, this is maybe something we have to do a little investigating on. But what I notice here is that I have a 60, I have a 5, and I have a 5. All of those numbers are multiples of 5, and so I could factor out a 5 first before I start the problem. And what I'll be left with is gamma squared plus gamma minus 12. And that's still equal to 0. So if you want to check your work, you can distribute this 5 back through and see what you get out. You will get the same thing. What that means is we can divide both sides by 5. And that allows me to say, okay, now what I have is gamma squared plus gamma minus 12 equals 0. Now this is a significantly easier problem, and I'm going to check for factoring now. So a times c is negative 12, b is 1, so we can use negative 3 and positive 4 for our factoring. So we got to option number 2, and we are at a spot where we can see that we have a factorable quadratic, so we're going to do that method. So let's go to the box method for factoring. I'm going to put my gamma squared here, and I'm going to put my negative 12 here. We said we were going to use, the reason that I'm doing that is because I have this here, and that has to go there. This right here is going to be from here. My negative 3 goes here, and my positive 4 goes here to match up with my positive gamma. So I'm going to rewrite. I'll have my negative 3 gamma and my positive 4 gamma. Okay, what is common between these two terms? It's probably negative, and it's probably 3. And it's both of those things because negative 3 goes into those two terms. That makes me have a 4 here. That makes me put gamma here and gamma here. Notice that my symbols are not perfect and they don't have to be, but I just am trying to show you some different types of variables, some different types of situations that you might see. Okay, so now what we have is we have the factoring for this quadratic. We can rewrite this as gamma minus 3 times gamma plus 4 equals 0. Okay, so then we have to zero product property. We'll say gamma minus 3 equals 0, and we'll say gamma plus 4 equals 0. Solve these two equations, and we'll get gamma equals 3. That's one solution. And we'll get gamma equals negative 4. That's the other solution. Okay, so there they are. We're done. Here's the next problem. Take a minute, think about what strategy you're going to use, and then try solving it. And here we go. Okay, now this one seems a little bit messier. I don't like this one nearly as much. I remember when I was looking at the A, B, and C to see if there's anything common to pull out. Doesn't look like there's anything like that. I definitely can't just get x by itself for the same reason, or this variable is called lambda. I can't get lambda by itself because b isn't 0. This one, I'm thinking, okay, AC is negative 49, B is negative 2. I can't think of anything that works there, so I'm going to cross this off. Can we complete the square? This works really well when we're in standard form, which we are, but it works best when A is 1 and B is even. We have that B is even because B is 2, but A is 7, and so this makes it a little bit more challenging. So I'm going to cross this one off also. That means that we are left with the quadratic formula. So I'm going to rewrite the quadratic formula for you. So lambda equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so let's rewrite what a, b, and c are. A is 7, b is negative 2, c is negative 7. So lambda equals negative 2 plus or minus the square root of negative 2 squared minus 4 times 7 times negative 7. All divided by 2 times 7. Okay, so rewrite 4 plus or minus the square root of negative 2 squared is 4 minus negative 196 all over 14. Continue down, we get lambda equals 4 plus or minus the square root of 200 all over 14. For this unit, I am kind of perfectly happy with you just picking this and circling this and moving on with your life. If you want to, you can give me decimal representations of those. Just make sure you do one that is 4 plus the square root of 200 over 14. And the other one is 4 minus the square root of 200 over 14. These are your two other answers. Either way of these is fine, or you can take this part and put it in your calculator, and then take this part and put it in your calculator also, and get your decimal answers. Next one. Ooh, look, we have x's. Okay. Now, this one, let's see, where are we at? Can we just get our variable by itself? It does not look like it because b is not 0, so we can cross that off right away. Can we factor it? AC is 16, b is negative 8, which means we could use negative 4 and negative 4. So let's factor it. There's a nice box. Okay, so we're going to use factoring. So we'll put x squared here to match this with this. We'll put 16 here to match this. We'll put our negative 4x and our negative 4x here and here to match with this and this, to match here and here, and to add up to this. So what goes on the outside? We get x, we have negative 4, we have negative 4. Okay. I did this quickly because I know that you know how to do it already, but just be careful. What we have is x minus 4 times x minus 4 equals 0. This thing right here, this thing right here is equivalent to all of this stuff together. So then, this is a little bit interesting because now what we have is we have a zero product property problem. So we have to split it. X minus 4 equals 0 and x minus 4 equals 0. And so when we solve, we get x equals 4 on this side, and we get x equals 4 on this side. Now, normally we have two answers, and we still kind of do. We still do have two answers. It's just that one of them is written twice, and that's okay. You should always get two answers, but if you only get one, that might mean that you have it the same one two times. We call this multiplicity 2. Okay, we'll talk about this a little bit next unit, but what you need to know is that this answer has multiplicity 2. This variable's name is beta. Okay, can we just get the variable by itself? Yes, we can, and the reason that I see that is because we're in standard form, but b is not written. So we can rewrite beta squared minus 49 equals 0, and just do opposite things to get x by itself, or beta by itself. So let's add 49 to both sides. We get beta squared equals 49. And then our two answers will be beta equals plus or minus the square root of 49. Wait, the square root of 49 is 7, so we can write beta equals the positive or negative 7. So you can circle this, or you can say beta equals 7 and beta equals negative 7. Either one of those is totally fine with me. Two more. This variable is the letter mu. Okay. Can you factor it? AC is 14, B is 12. I can't think of anything that multiplies to 14 and adds to 12, so we can't do the first two. That means let's try completing the square. And the reason that I say completing the square is because A is 1 in this problem and B is even. And so we are in a good spot to complete the square. So let's do it. Normally when we complete the square, we put our variable squared term right here. So we're going to put mu squared. Oof. There. We're going to split our B term. The reason I'm doing this is this matches this. We're going to split our B term, which is 12 mu, here and here. So we're going to write 6 mu there and 6 mu there. Okay. What do I get on the outside of the box? I get a mu here. Oh man, that's a horrible one. And a mu here. Then I will have a 6 and a 6. That means that I will put a 36 here. But notice that's not what I have in the C spot. So how do I get there? I need to add something. I need to add 22 to both sides so that I get here, this is 36. So rewrite. What we have now is we have mu squared plus 12 mu plus 36 equals 22 because we added it to both sides. Now on this side, this whole thing is a perfect square. It is the perfect square mu plus 6 squared equals 22. Now we can solve for mu. We can get mu by itself. So we're going to rewrite this as mu plus 6 equals the plus or minus square root of 22, and then subtract 6 from both sides. So we get mu equals negative 6 plus or minus the square root of 22. I'm perfectly happy with you circling this and moving on with your life. So that's our completing the square process. I just want to remind you of that. Last one. We got x's. Okay. B is not 0. We're in standard form, but B isn't 0. Does it factor? We've got 36 and 8. I don't think that one works, so we'll move on. You might be able to find one that factors there, I'm not sure, but I wanted to show the quadratic formula one more time here. So this is a bummer of a problem to try to complete the square. So we're going to try the quadratic formula. So A is 3, B is negative 8, C is negative 12. I encourage you to write out what those things are before you start the problem. It just helps you remind yourself and stay focused. So x equals negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 12 all over 2a. Okay, so then I just have a bunch of simplifying to do. So I have to write x equals 8 plus or minus the square root of 64 minus negative 144 all over 6, okay? Rewrite x equals 8 plus or minus the square root of 64 minus negative 144 is 208 all over 6. Okay, I am perfectly happy if you just circle this entire answer. Okay, you can certainly write it, you can certainly split it up, or you can certainly give me a decimal. Remember that you should have 2, and I'm done for the day. What I want you to do is do almost exactly this thing. So I'm going to keep this list up here. You should keep this list up here. Maybe you should even go back to that slide where it was all on the whole screen. Screenshot that slide, use that slide for today. What I'm looking for you to do is to think critically. What strategy works the best for each problem? How are you going to choose it? Make sure you know how to do all of the 5 strategies. And then do the problem. Make sure your answer works, and then move on. Okay? Have a great day.